And this course is for the first optional course for the computational communication studies. I will very briefly introduce how to use R for programming and data analysis. And when we are talking about the computational approach, actually two techniques are involved. The first technique is programming, and the second is data analysis. I think most students at the very beginning can tell the difference between programming and data analysis. Actually, they are two very different things. I think some programmers, they can develop a very fantastic software like Microsoft PowerPoint, but actually they know nothing about how to do data analysis, and they even didn't take any course on statistics. I think most of you may have some basic knowledge on statistics, but you actually don't know how to program. How to write a program using like C# or R or Python to write a program to do regression. If you can, I think you don't need to say here, okay? If you can, I will tell you, I think most of you may familiar with how to use SPSS to conduct some very naive, maybe not so naive statistics. But think about that, if you don't know, if SPSS do not have function for your own purpose, I think you have no idea how to do the statistics. Even the model is very well developed. So in this course, I think you have to use some programming languages like R, and then you can write your own programs to perform sophisticated statistical data analysis. By the way, I have to say one more thing about data analysis. Actually, there are many kinds of data analysis. Statistical analysis is just one of it. Okay. You may heard the term data mining or natural language processing or something else. They are all about data analysis, but they are not statistical sometimes. What I mean statistical just means that we don't have any assumptions about the distribution of the variables. Okay. But in this class, we will just talk about statistical analysis. Okay. So in my lecture, I will basically talk about two things. Have two sections. In section 1, I will talk about programming tools. I will first talk about some basic syntax, and then go to introduce data structure, and following some commonly used programming tools. And in the second section, we will talk about data management, and then I will show you how to do some basic statistics that you maybe have already familiar with. Okay. So this class is basically very hands-on oriented. So I will not use this slides again, and I will just show you how to just follow me to how to do write some syntax. Okay. Oh, sorry. There are some readings we have to read. But maybe tonight you can read some reading materials tonight about tomorrow's class. Okay. So just over R, I will not introduce how to use RStudio. RStudio is actually just the IDE of the R. I don't think it's necessary, but it will actually speed you up when you write some code. Sorry. First, you can open a new script, and this is here is a new script, and the first thing you should set your working directory. What is working directory? That means your working directory is the folder on your computer and in which you are currently working. When you know something, you want to know something or save something, that is, the default folder is the working directory. So first you should just name it. No, I can write the syntax to this task. But I will show you how to use the menu. Where? Oh, you should click this one. And then here is a change your working directory. I will set up my working directory. Users. Sorry. Desktop. Here. Now. The better way. Write the syntax to this task. I have downloaded a folder from the Facebook, and I think you may get this one from review. Okay, I have downloaded the first one, the R review, and we'll use a lot of the data from here, and I can click it, just copy paste, and I will write a syntax called set can you. Yeah. No. Too small? Yeah. Okay. Set means set working directory, and then I just copied the path. And you will like this. I will change this one, the slash. Open the folder, for example here, just click. Just click. You can download it, yeah. You can download any. It just depends where you store the folder. I can put this folder in any place actually. For example, I can copy this one in E.
Download the PDF file you uploaded on Facebook.
Yeah, okay. And you can also request the presentation. But tomorrow all will. Everything will be fine tomorrow, okay?
Oh, okay. Sorry.
For example, I can change this one and use another folder. Looks better, okay? And just click. You have several ways to run this code. The first is just click Control R. And then using Control R, and you will see. Let me do it again. Just Control R, and you will see. Actually, we have done. And here we also can input some syntax. For example, I will see what documents in this folder, and use ls. No, nothing. Why?
It's default.
Huh? What's wrong? Okay, you can use dir. Okay, you can see there are 50 files in this folder. Okay, this is the first thing, and the second thing, I will introduce the most useful component in R, the so-called the package or libraries. Because we do if you want to do some statistics, there are some people may develop some very good library or packages. You have to know and use the functions in this in this package. For example, library. We know the package called TM. That is, then we'll use this package to introduce how to do text mining. Library TM. See what? There is no package called TM. That means we don't have this package installed correctly already. So we should first install a package. Install packages. TM. Okay. Now we can choose a server location. Let's choose that, and then we will download the package and install. It might be slow. Too slow. Okay, it's okay. Library, and then we click library. Okay, we can use this package. If you don't know how to use this package, we actually can use a function called help. For example, help packages, package equals tn, and then you will see. Okay, then we'll open a web page. We will see there are a lot of functions here, and we can use. Don't worry, we will talk about this tomorrow. No, on Saturday. Or tomorrow. Okay? No problem? Okay, maybe it's too easy. And the next step is just to input and out, to input or output some data from, for example, we can import the text files, CS files into R. Here we have some data, for example, in my folders. For example, this one, this is in the CSV file, and here is a text file. We open it. It looks like this. This is just, I think most of you are familiar with just a data table with the column names, the variable names, and there are many cases in this file. How to read this file into R. And it's actually in R, it's very easy. Use data read, use a function called read table. Use read table, and then we just need to input the type the file name coordinate. This text file. Okay. And Control R, and now it has read the data. We can scan this data use a function called head. So we just scan the first 6 rows. Okay. Now you can see the data. Like this, var names, OID, UID, author name, locations, college, discipline, and discipline department, email, and so on. So any problem, question?
Can you say again how to upload this package?
Upload the package.
We download it from the email, but we don't know how to use it.
Set the working directory.
Yeah.
Just use this one. For example, you have downloaded where you store. Maybe then they can help. Thanks. And you can see the data have been loaded, and then we also can import the CSV file. The CSV file looks like just in Excel right? Like this one. And we can use a single function called read.csv author list.csv. Okay. Let me check. Okay. Okay. Same. Right. And the most powerful thing is that we can even import data from the SPSS format or data format. Even you don't need to you even don't need install the SPSS or data on your computer, but you can import the data. Here we need another library called Ori. Okay, and then we load the data, use the function read.spss, and the file name also is sav, and I will show you data. All messages in R. Actually, in most programming languages, that means something you can completely ignore. Okay. Check it. Okay. See? It looks very different, right? It just that the problem is because we use read SPSS, use this function that just load the data in another format, in a vector format. So it looks very different. So we want to see a data table. We need to add one more syntax here, two data frame. I will see what is data frame later. True. T means true. Okay. And run this line and check. Right now, OID, UID, and also names. And we also can read the data in stata. ETA also means ETA. Right? It's okay? One minute. Okay, I will show next. Do some basic syntax. We can do some basic. I just show you how to do some basic calculations using R. For example, we can use 1 plus 2, 1 plus 2, 1 multiplied by 2, 2 by 2. Okay, I think that's very easy. So you can try this. Use that one divided by 2 and minus 1, for example, minus 1 plus 2. It's very easy. Okay. I just show you how to use this one, but it's not so useful. Okay. And next, I will show how to assign the values to a variable. For example, we create a new variable called Liang, and then we assign a value to this variable. 108. And then, by the way, the warning message and the error message are two different things. Error message, that means you have to find a way to solve it, but the warning message, that means you can just ignore, okay? And the variables, okay, we use another variable, for example, the height, and we can assign a value to it. Use the equal sign. Actually, you can use the arrow sign. Like this. Actually, the two are equivalent, okay? And we assign another called weight, for example, we see with A. We run this. And you can see height, we type height, and we see 180, okay, weight 15, and then we can do some calculation based on the variables. For example, we want to multiply height by weight, and wait, split. Actually, that's equal to 180 and multiply by 2. That's right. Just for illustration, okay. Yes. Any problem? Okay, the next we can actually R has some generic functions. We can use them directly without node any libraries. For example, we can use the sum function to calculate the sum of the numbers 1, 3, 4, 5 in this way. No, we may first create one. Use the C. C is a function I will introduce later. It's just, this means that 1, 3, 4, 5 is a vector actually called 1, 2, 1, 3, 4, 5, and we'll calculate the sum of the 1, 3, 4, 5, and we use the function called sum. Okay, that is result. And we can also calculate the mean, use the mean function, that is 3.25, okay. If sometimes you may find you don't know how to use the function sum, but you just remember the name sum, so you can use the help function, and we type help sum, and then what, C. I will see this, and it tells how to use sum. How to use this function. For example, here is a numerical complex logic vectors. It's just like 1, 3, 4, 5, okay? And then NA remove. This means you can remove some missing values. I will talk about this later. But here we just want to show you how to use the function. Okay. The next I will introduce I will introduce the data types. In R, actually there are three most important modes of data in R. It calls string, numbers, and logic variables. The first string variable, for example, I will assign value to a variable called string. This variable I call string, and I can input a string here. You can everything. For example, I am Liang. Okay. I will see what the variable looks like. It looks like this, and Liang is just a string or means character. We can use another function. We can use a function for class to examine, to check what type of the variable. Class string here, that means the variable is a character. We can also use another one for type of string. It's the same, okay? And the second type is called numbers. Numbers, I just show you for the numbers. For example, it can equals 15 number. Here is a number. See, I just type number, we can see it's 15, and we use the class function number. That's numeric. Okay, it's a numerical variable. And the third one we commonly use is logic variables. For example, the logic variable, there are two predefined variables that in the logic variables. It means true and false. True means that true. No, it's wrong. True. Logic true. For example, this one called the variable name is logic 1, and design value true and false. And we will see what is logic. Logic 1, true. Logic 2, false. Okay. The class of logic. Logic 1 and the logic. Okay. And finally, I will introduce the missing value. How to deal with missing value in R? We use NA. NA means indicates missing values. They are missing is then equals NA. And we see that missing. And then if we check the class of the missing variable, that is a not. In R you treat it as a multiple variable, but you can use another one. Is NA means to check whether the variable is a missing value. We can use the is.NA function missing, and we see true. What does that mean? That means the missing value, the missing variable is a NA value. Now you can understand why we use class. Class missing. Why it's a logical variable? Because actually we use class variable on missing. It will return a true value. True is a logical variable. Not NA is NA actually is a NA type, not a logic type. But the class missing return a true value is a logical variable. Okay? Is a logical value. And in the next section, I will introduce the data structures and the programming tools. And I just tell you, to learn any programming language, so shortcut to learn is just focus on the core elements. And what is the core elements? Fortunately, most programming tools may share very similar core elements. They are the data structure, and the conditional expressions, loops, and the functions. So I will illustrate some examples of how to use the data structure, conditional expressions, loops, and functions. Okay. So the first one is show the data structure in R. Actually, there are three or maybe four data structures in R. Here, I will show you this one. This is a good picture. There are four here. There are four data structures listed here. The first one is called vector. What is a vector? Vector is just a list of values. We just show you 1, 2, 3, 4, 5. That is a vector. And there are, if you have many columns of vectors or many rows of vectors, that is a matrix. Look like this one. And we will not talk about this one because we usually don't use this type. We call what is data frame? Data frame means it actually looks like it's very similar to matrix, but the difference is that in vectors all values should be in the same data type. For example, numeric all should be numeric, logic all should be logic, string all should be string. In matrix all should be similarly. All values should be in the same time, but in data frame, you only require the columns in the same time. For example, the column 1, we use the numeric values, and column 2, we use string values, and the third, we can use logical values. It's okay? So what is a list? A list is just a combination of all vectors and data frames or lists. You can put everything in list, in your list, in your variable for list. Okay? So I'll show you how to create and how to manipulate this one. The first vector, we create a vector with the C function. I just show you the C function, and we put the list of the values here: 1, 2, 3, 4, or 7. Okay. Here is V. We put next in this one, next this, and but how remember that all values should be in the same time, but if we put the value in different times, for example, two numeric, and then I put a string here. So what do you think? What's the result? This is a try. It will look like the numerical 1 and 2 has been changed to string. The R has forced the numerical values to keep all values in the same time, so they force them to be string. Okay. We can access any elements of the vector. For example, we want to access the second one. The second element, we use the bracket 2, V2. This is the index. The second one is that is 2. Okay, 2. How about the third one? The third one, H. Okay, that's easy. We can use -1. That means except this one, except the second one, and so the result is 1 and 8. We can work the the most powerful thing in R is that we can use vector to do some calculations directly that we call vector calculations. For example, we can multiple V by 2. The result is that means 2 every element by 2, and the result is 2, 4, 6, 8. Okay, but if that's not the same thing in other languages like C. If we want to do this task, it's very actually it's not so easy. we have to use a loop. For example, I will just show you. I will later tell you how to use the for loop, but just here I will just show you an example. For example, we want this task in C or other language. We have to I in V. We should do this in this way. When I in V, that means print I times 2, and I would say, okay, we have to do it in this way. That's too complicated. So we just here we just show you how to use the. We can directly multiply by 2, and we also can calculate the square b. Okay, the next is the matrix. We can generate a matrix use the matrix function. For example, here I will write this. This means that we generate a matrix with 5 columns and 5 rows, and the value in these 5 columns and 5 rows, that means there are 5 times 5, 25 values, and the values is from 1 to 25. That's what I mean. What the function here means. And if you don't know how to use matrix, I just help matrix here. Matrix, the data, number of rows, number of columns. Okay, this is the number of 5 rows and 5 columns, and I will see n. I will check what is n. N is moving like in this way. Okay, 1, 2, 3, 4, 5. The values is from the integer from 1 to 25. Okay, we can generate this matrix. And similarly, we can access the matrix use this way. For example, we want to access the second column, the second row and the first column. Second row and the first column. Okay, that's 2, right? And row 4, column 2, column 3. This one. We can also use to do some mathematic calculations. M plus 2. See, every element in this one have plus 2. M plus 2, and then n multiplied by 2. 2, 4, 6. See? We can add 2 matrices together. It's similar. The result is same to n multiplied by 2. Okay. Any problem? Are you okay? I will show another useful function called, we can combine 2 matrices. For example, here is a matrix with 5 columns and 5 rows. But I want to use this one, combine. Column combined, C bind. Okay. That means we combine the 2 matrices by columns. And we add 4 more columns here. The M matrix looks like this. And if we combine another, we can combine append. another n matrix here. It will look like in this way. Another function is called zone bind. That means we pinned under the matrix. Okay. Here, see. Okay, the next one is data frame. Actually, when we perform any data analysis, before that we will transform our data into a data frame. So that's very important. As I just explained, the data frame is the spatial matrix. The columns can be different data types. For example, here we create a vector called v1, and it's numeric 1, 2, 3, 1, 2, 2, 4, with 4, and then the second vector is the with logic values true, true, false, false, true, false, and the third vector is numeric. For example, yes, yes, no. This is a string character. Okay, number 1 together. You see, v1, v2, v3, and here we can create a data frame use the function data frame, and v1, v2, v3. That means the three columns, okay, in data frame, and we should add one more sentence here. String s factors equals false. Okay, and wrong here. You see what it will look like this. v1, v2, v3. No. Actually, here we just to create a new columns, so it must be wrong. Here, this string as factor becomes a new columns here. There are 4 columns. The first variable is v1. It's numeric. For example, we can check class D. We use the dollar sign. Okay, I will write class D. Use this sign to access the variables in the data frame. For example, v1. I will see what will see class numeric. Okay, and we see the second variable d v2. It's logic. Okay, class d v3. It's factor. It's a factor variable. Why? It's not a string. I just said. Here is because of this one, I will check the. Oh, there is a mistake. It's not string as a factor, it's a strings as factors. Okay, we wrong here. Here, you see? Okay, right. Right now it's three columns. The column names is v1, v2, v3, and here we check the data type of the third variable. B3. Now it's character, okay? Okay.
Sorry, what does string as factor mean?
That means we, for example, if we do not have this one, then we'll just transform the V3, this vector. If this vector is a character, okay, but we create a data frame that will convert to factor. So we don't want that to be a factor type. We just want to convert the vector to be numeric, string, keep in string format, okay? So this sentence is a string as factors equals 4. Next one is list, and list is very simple. Just you can combine. See, we have a vector like this, and a matrix like this, and we even have a data frame like this one. How to create a list? We just list function, and we have a vector, matrix, and a data frame, and we create a list called. The name is list. Check L. L is like this one. And the first element, for example, we check the first element is a vector, okay? And the second is a matrix like this one. And the third is a data frame. We just combine all together in a list. So we can access the list with L and double this, double. The first one we see, it's a vector, okay. The third one, if we change it to 3, it's a data frame. We can check. Class L3, it's a data frame, okay, right? So it's correct. Okay, next I will introduce you 3 programming tools. The first is how to use the if-else expression, and then which is just one of the conditional expressions. And then the second, how to use for and while loops. And finally, I will show you how to define your own functions. I just show you how this C is a function and its data frame is a function. Actually, you can define the function for your own purpose, okay? So, for example, here is a task. The task is just input a number. If the value is larger than or equal to 100, and then you will print a high value. For example, we need to the input is a number. For example, we input a number here, and if the number is larger than 100, we print. We need to print. We ask the computer to print. Print what? Print. This is a high value. Okay. And if this is from 15 to 100, and this is we print called middle value. Okay. And if we less than 15, this is a no value. We just do this. I'll show you how to do this one. Use the here. First, we want to input a value. For example, here is 78. You can input any variable here, and we use if else, and here is insert the conditions. Here if x, larger than or equal to 100. So print type, okay, else if x larger than or equal to 15, and this means and. It's the logical operation, so you can check this on any R books. You can find how to use the logical operation or operators in the reading materials. Okay, OX smaller than 100. Print. And else. That means always. Always. Print. Print is a function, just no. Okay, we can run. See, that means 78 is a middle value. You can change here. You can program to 200. And then we will plug in as a high value. Try it. So next I will show you how to use loop functions in R. So here is a task. For example, we have a vector course names. That's actually our instructor's names. For example, like Hi and Jen and Jonathan and Jim. So the task is first we have a vector. That means we have 4 names of our instructors, and here the task is that we need to calculate. We need to calculate the number of characters of each name. Okay, here are the 3 characters, and this is 2, 4, whatever. There are several characters in it. So we just want to do this task, and I will show you. We will use a new function here called n character, means the number of characters to calculate the character of a string, for example, hi. There are 3 characters. Okay. So, but how about if we want to calculate all these the 4 names? And we can do it in this way: character, and so it's not actually it's not efficient one, right? How about if there are thousands and millions of names? So it's not good way to do. This is not good way. Okay. So we have to use a loop. Just loop over this one. For example, I show you 4. We use a for function here. For example, name in names. The names is vector. Okay, the name is here we define a new variable actually called name. Name in names means that when Hi is in names, Zhenzhen is in names, Jonathan is in J's, okay? I mean we use one by one, we use name one by one, and we print number of characters name. We calculated the number. Here is a number we call n, and here we print. We print n. Actually, we can here. We can print n first. Later, I will improve this one. But here we just do this. E. We can, instead of using the control R function, we may have a better way to run. Where? Run. For example, we put the mouse here and we run. See? If you don't want run. And we just copy this one and we can. We can improve this one because we don't know who is the whose name is the 3 characters, whose name is 88, so we can improve. Use the paste function. Paste name. See, the paste the function means that we paste the name. For example, Hi or Zhenzhen or Jonathan. N is this variable. Okay, we get this one and run it. We see what? Hi 3, Zhenzhen 8, Jonathan 8, J 3. Here we just loop this loop the names over this over the vector. We actually have another one to overloop the index. For example, here we have four values here. 1, 2, 3, 4. We want to loop from 1 to 4, and we calculated the number of characters. What's the character? That is in names. Here names. Not 1 for. Actually, we should define a new variable for I. For I in 1 from 1 to 4. And here we access. I just mentioned how to access an element from a vector. This is I. For example, the first one is I. First is 1, second is 2, names 1, names 2. Okay, here is the same. We just copy paste. And we need another print I to check what happens. The first, second, third, fourth, first J, Y. So what's wrong? This 3, 8, 8, 8, 3 is right, but name is wrong because here the name is J, but we don't. What we need is name I. Here. Are you okay? Seems tired. Any questions? If no, I will move on. We have a lot of things to talk. Instead of using the for function, actually you can use while function to loop over a vector or a task, but we don't have time to cover it. So please do it when you have time. I think I have the right one. For loops, actually we can use the while function. Okay. So next I will talk about how to define your own functions. We define a function. For example, we can write a function. We write a function to calculate the area of a square. That means that we can, for example, we use width. We have a variable width, 20, and then height is 21, and the area. Area is use the width multiplied by height, right? As a result, but how about if we want to calculate many values, many widths and many heights? So we better to define function. For example, we define the function called area and use the function. The function actually is a function. Function look nice in this way, and here we should here is the place of parameters. Here we use two parameters, width and height, and we need to calculate the area equals width multiplied by height. Okay. And here is the most important thing. We should return a value. The value is, here I will change this one, the variable name. Actually, this is the result. We should return a result, x. That means we input two values here. The first value calls width, and the second value calls the height, and then we want to get the area of the sphere. Okay, so we write a function called area. I'll show you how this works. Along this one, and we use area. We input the value 20 and 20 and 21. See? And 420. Okay. That is the same result. We can change this with 200. And then we can change the values. I don't think I have enough time to talk about how to use R to do statistical analysis, but I think that's very useful for in your research. So I think it's better to download my slides and read the slide and try the exercise here. But I have half an hour, so I will talk something more advanced. How to use the R to do data management. That's very useful actually for in the next 2 days. So. So I'll just try to focus on how to use the data management functions. We create a new script. Here is the data management. You can do some note here. Use this slide. And for data. Okay, for that have nothing. So first we'll know the sample data. If you have downloaded my data, okay. Sample data, we know. I will use the data for instruction. This is sample data in my folder. The sample is R, the data type is R data. We use the node function. Okay, node. So I will show you what is the sample data. It's not sample. Actually the data name is not sample. It's TST3. See, look that's this way. I will introduce a new function called column names. We can just to see what the column names and the variable names. We use the column names to check the variable names. The first is the ID. Actually, the data is connected from New York Times, and I will tell you how to connect this data tomorrow afternoon. Now we'll just use this one. No, it's not. The file is called sample. When you know okay. Sorry about that. Now load the sampler data and check the TST3 data frame. TST. I will introduce first the column names, the variable names. First the ID, that is the New York Times news article's ID, and it has a section name. For example, this article is from the world section, and this is from sports section, and the next from travel section, and this is the publication date. And then we have abstract of this article, and the need paragraph, but that means the first, the need. You are from DS school, so you know what is need. And the word count, that means the word count of the full article. Okay, I will use this one for illustration. Okay. So first we can how to manipulate the data frame. The first task we need to do is how to create a new variable. How to create a new variable. Actually, this data frame is similar to what you see in SPSS data or any database software. Okay, how to create a new variable. It's very simple. For example, we can create a new variable called WC, a word count here. I will check first the class, the class of the TST3, the word count variable. The word count variable, it's a character. Though it looks numeric, but actually it's a character. So we need to change. We need to convert the string variable to numeric. Okay, and then we assign the value to a new variable called WC. So we use as numeric. And here is the TST3 word count. We convert this one is a string back is a string vector, okay? We as numeric means that we convert it to a numerical type. So run this one. Now we check. tst 3. Here we have, right? We have new column. We have new variable. Next, recode. We usually use this function in SPSS. How to recode? You can recode the WC a variable into a binary variable according to the word count. For example, we recode into a binary variable with some to indicate the non-articles or short article. For example, we define the word count larger than 500, we say it's a non-article, and less than 500, we say it's a short article. We just create a new variable. For example, create a new variable called none. That means indicate that's a non-variable or short category. So we use this one, how to tst3. We use the function called within tst3. To tell you the truth, actually you can use very many ways to recode a variable, but just want to introduce one of the just one of this. Okay, tst and the variable new variable called now na. Now equals na means that we initiate a new variable called now, and all values are na. Don't ask me why, just keep this one. You should do this to create a new variable. You have to create a new variable, and at the same time you should assign value to them. When you don't know what are values you should assign to this new variable, the best one is just to assign a missing value to them, right? And second is now. WC and WC larger than 500. When the word count is larger than 500, and we see the new variable now is yes. That means yes, it's a non-article. Okay, and then when now word count is smaller or equal to 500, and it's equal to no, that means no. Okay, let's run this one. What's wrong? Where? We should reorganize this one to check what's wrong. Nothing wrong. Oh no, we don't need this. We don't need this. It should be look exactly what you see on the screen, okay? That's hard. No, you don't know the joke. Here you can see that we create the new variable. Now we recode the new variable from the word count variable. That is this one is 300, so less than 500. That's not a non-article, and the next yes, okay. Okay? So the next we can how to rename a variable name. For example, we want to rename the section name. We think it's to none, and we want to rename this one to section. That's it. We should use the column names. TST3, that's the data frame name. And this is the second one. So here, the first one is ID, and the second one is section name. And then we assign new value to this one called section. Okay? So check TST3 BC. The section now. So next is how to subsetting a data frame. Sometimes we just want part of the data. For example, just several rows, or sometimes we want several variables. That means sometimes we can just select some cases, but other times we want to select some variables. Okay, I will show you how to select the variables. There are many ways to select the variables. We create a new data frame. The new data frame is a subset of the TST3 data frame, and we only want to pick the first and the third variables. That means we just want we're only interested in the ID and publication date variables, as we have several ways to do this. First, the first one, the first column, and the third column. So C. So what's wrong? Oh no, we need a function called C. That means this is a vector. We need the first and third. Let's check. What's going on? Right. And the second way. Second way is just tell the computer the column names. The first is the first column ID, and the third column publication date. Okay. See. I say. And the third way, no, the third way is names. TST3. First we see what is names. Names is a function. Actually, it's column names. Use a percentage sign and in. That means this is the vector, and in. Right? This is a vector called ID and publication date. And this is a name vector with 6, 7, 8, with 8 variables. That means we only need the column names in ID in this vector. We only need the columns whose name in ID and the publication date. You know this. Actually, there are too many other ways. The next, how to select the observations. For example, we will only want to select the cases. Only want to select cases which satisfy the condition none equals yes. That means we only want to select non-articles. The way is use similar but different. Use the which function, which what? TST3, the variable, the non-variable equals, use equals, yes. That means we are only extract, we only keep the cases, the non-article cases, okay? TSP3 now, this is a variable, the non-variable equals yes, which, comma. See? Aggregating is also a very useful function in SPSS. So it's very useful to summarize data. For example, calculate the average length, the average article length by by section. So we want to see all articles posted in the Word section, and we want to calculate the average article length, and so we use the aggregate function, aggregate. The word count, and you use a sign section, that means we bind the word count by section, and the data in the TST3, and we need to input the function, this function is new, so we want to know the average here. We have to see what. When you run this syntax, you can get this results. And for example, the section auth, the average word count is 1,000, and the article is 800, and the auth now whatever. See? We can use this function in another way, aggregate. By I think this one is more intuitive. We want to know the average word count, and we buy at least here just one variable section. Okay, we can get the same result. Design name. Design name. Next, how to calculate the number of articles in each section, and we can also use the aggregate function. Aggregate 3 and aggregate. No, we need one more to do one more thing. We need to create a new variable n equals 1, and why we need to do this? We create a new variable called n, and all values are the same 1, and then we can sum these numbers to 5 sections, and calculate the sum is actually the number of the total number of the total number of articles in this section, right? So aggregate n and by function, by section, and tst 3, and here the function is not mean, but sum. See, 16 articles in ours. Okay, actually we can do it more. We can calculate the two variables at the same time. We use a combined function here, and for example, we want to calculate the sum of the word count and also the n together. So, see the results will look like this. This is the total word count of this section, and this is the number of articles. If we divide, we will get an average, the mean. For example, here we divide, we calculate a new variable for average, and then we use word count. And see. This average. Now we're back to aggregate, or the first data set. Aggregate 1. We see that each section will have a word count average and the same, right? Compared to the original TST3 data frame, actually we have a word count for each article, but now we want to do a task. That means we want to merge the two data sets, the aggregate 1 and the TST3. We want to merge the two for what? Into one single data frame, and to see whether the word count here, the word count in the TST3 data frame, the word count of each article, whether the word count is greater or smaller than the average of the section. For example, the first article is 390, and it belongs to the word section, and the word section, for example, the word section average is 1,000, and we want to see whether this one is smaller than average or greater. So we need to use a very, very useful function called merge. Understand? Okay, great. So first we should rename the column names. We want to rename the column name. That one, this is called WC. We want to change the verb name to average. Section average. Okay, section average. This actually is section average. Column names. Okay. To take care of the spelling. To the section average, and then we use the function converge. TST3 we want to merge TST3 and aggregate data, and we use the function by section. That means we have two data. First, the data is aggregate 1, and the second is this is the first TST3, and this is one aggregate 1. We want all arts. We want to append the value. For example, here the arts section, and the section average is 1,100. So I want to paste these values to the TST3 file with a new column called section average. Okay, and so we by the by is identified. Actually, they're called section. So we will run this one, and then we see what happens. TST3. See, this is section arts. All arts articles. There are many articles posted in the arts section, and this is the section average. Okay, and this is word count of these articles, and here we can compare. This one is smaller than section average, and this is smaller. Okay, and this one is larger than the average, the section average. Okay. Understand? Oh, sorry. I think I have to stop here. Right? So I think in my just several more words. And there are many content I don't have time to cover. I think if you have time tonight, please do it. Okay, we have more things about how to do data management, how to convert between the non-data fat data. If you don't know what is non-data fat data, I think tomorrow morning you will find it very difficult to understand what Jonathan will say.